Functional groups are described as such because they do functions in chemistry. That is, they are capable of performing reactions. Functional groups are reactive because they are polar or polarized. Examples of such functional groups are those containing the CX bond, as in alkyl halides or haloalkanes. Halogens in the CX bond, in general, are more electronegative than carbon. Therefore, the halogen pulls the bonding electrons in the CX bond more than carbon, causing an equal shift of electrons. This is described as inductive effect. The difference in electronegativity values between the halogen and carbon induces bond polarity. Therefore, the CX bond is polar. Examples of functional groups are those containing, for example, the CN bond, as in amines, the carbon-nitrogen double bond, as in amines. What's going on? I hear voices. Do we have intruders here?
What about the carbon-oxygen bond? No mention of it?
That's right. Isn't the carbon-oxygen bond polar?
Dear carbon and oxygen atoms, I didn't really mean to offend you at all.
And as if I'm not an electronegative atom.
He didn't even mention that you are more electronegative than me.
Carbon, oxygen, mass, you didn't really give me a chance to explain.
All right then, go on, we are listening.
Yeah, tell us, what can you say about my bond with my body carbon?
The carbon-oxygen bond is polar.
Not bad, doctor. What else?
Please, doctor, say it. Please say I am more electronegative than carbon.
All right, folks. The carbon-oxygen bond is polar because oxygen is more electronegative than carbon. The electronegativity value for carbon, according to the Pauling scale,
It is 2.5.
Carbon, all right, oxygen is more electronegative than carbon. It has actually an electronegativity value of,
Oh God, it's 3.5.
the bond between carbon and oxygen is a polar covalent bond because oxygen is more electronegative than carbon. In this carbon-oxygen bond, oxygen pulls the bonding electrons toward itself more than carbon does. Therefore, this inductive effect leaves a negative partial charge on oxygen and a positive partial charge on...
Doctor, hold your horses. I have an idea.
Really? What is it?
Actually, we both share the same idea. We had discussed it and agreed on it on our way here. It's quite nice, quite provocative.
Informative, interesting, fascinating, illustrative.
Atoms, you have excited me. What's your plan?
Oxygen, can I talk?
Yeah, of course, carbon. Go on, my friend.
Oxygen and myself have been thinking of demonstrating the polarity of our carbon-oxygen bond and the inductive effect by row pulling.
That's right. Since I am more electronegative than my body carbon, then I will withdraw the bonding electrons toward myself more than carbon.
All right, carbon and oxygen, demonstrate to us the polarity of your bond.
Come on, bonding electrons, come with me.
Of course I am more electronegative. I am pulling the bonding electrons more than my friend carbon.
Keep going, oxygen. Pull electrons toward yourself more than carbon. And you too, carbon. Continue, keep trying. Pull electrons toward yourself more than oxygen.
I will not disappoint you, doctor. I am pulling. I am trying.
You can't, my friend carbon. I am withdrawing the electrons more.
Now we can see the difference clearly in electronegativity. Oxygen, being more electronegative than carbon, it pulls electrons toward yourself more in this bond.
I wonder why I am less electronegative.
That's a good question, mate. What makes me more electronegative than you?
That's actually a legitimate question. Why is oxygen more electronegative than carbon?
I have an atomic number of 6, an electronic configuration of 1s2, 2s2, 2p2.
I have an atomic number of 8, an electronic configuration of 1s2, 2s2, 2p4.
Great. The bonding pair is in shell or energy level 2. In both carbon and oxygen atoms, the bonding pair is shielded from both nuclei by the 1s2 electrons. In that, therefore, they are equal.
That's right, Doctor. However, there are 6 protons in my nucleus.
And there are 8 protons in mine.
Therefore, the difference is really in the number of protons. There are 8 protons in oxygen, while there are 6 in carbon.
But I am still confused. Why am I less electronegative than oxygen?
That is because I have more protons.
Oxygen is right. Oxygen has 8 protons in its nucleus, pulling 2 bonding electrons shielded by the 2 1s electrons. The net pull, therefore, is plus 6.
Yeah, I got it now. For me, I have 6 protons pulling 2 bonding electrons shielded by 2 1s electrons. The net pull is plus 4.
So my nuclear charge plus 6 is more than that of carbon, that is plus 4. Therefore, I attract the bonding electrons more than carbon does.
Oxygen is more electronegative than carbon because its nuclear charge is more than that of carbon. The bonding electrons are then pulled closer to the oxygen atom than carbon. The carbon-oxygen bond is a polar covalent bond as demonstrated by the rho pulling beautifully performed by carbon and oxygen characters.
So our carbon-oxygen bond is polar covalent?
Yes, it is a polar covalent bond.
In summary, bond polarity is caused by inductive effect, which is a result of unequal shift of electrons in covalent bonds caused by differences in electronegativity values. Bond polarity is a major cause of reactivity in organic chemistry.
So we are part of functional groups?
Oh yeah, we are present in ether.
And carbonyl compounds such as aldehydes and ketones.
And carboxylic acids and carboxylic acid derivatives.
That's right. To wrap up, the carbon-oxygen bond is a great example of a polar covalent bond that's present in a wide range of functional groups.
Are we done here?
If the doctor says so.
Well, that's about it, dear carbon and oxygen atoms. Thank you very much indeed today for your exceptional demonstration.
Our pleasure, Doctor.
Our honor, Doctor.